Okay, in this video, we're just going to find the volume of all of the different shapes that we're held accountable for in the 8th grade. So I'm going to assume throughout the video that you know how to look at a star chart or a formula chart, look up a formula on Google, or use the cheat sheet that was printed out for you to have all of the formulas for each of these different shapes. Now, the different shapes that we're responsible for in 8th grade are spheres, a rectangular prism, or a cube, a triangular prism, a cone, or a cylinder. We'll notice that the first 4 problems are all spheres. The volume formula for a sphere, take a second, see if you can find it on your whichever method you're using to find volume. The volume formula for sphere is 4/3, 4/3, times pi times r to the 3rd power. We typically use 3.14 as an approximation for pi, or an estimate, a really close number to pi. R stands for the radius. We can see the circle in the sphere right here. There's really circles going in every direction, right? Through this circle, though, from end to end, from what I can assume is the middle, is 12 feet. That's actually the diameter of that circle, or the diameter of the sphere. So the radius would be half of that, which is 6. All we need in order to find the volume of a sphere is the radius. So from here, I can just rewrite my formula. 4/3. Most of you are using times 3.14 times, and then instead of r, we have a bubble, because I'm going to put a number there, to the 3rd power. The number for r is 6. From here, this is really just a calculator problem, unless you have some aversion to using the calculator and would like to do 6 to the 3rd power by hand. So I think we can see the calculator screen pretty well. Yeah, it's better that way. Okay, so we've got 4/3. 2 ways to type a fraction in. The way that we're trying to go with in class is using the alpha button, the green button, followed by y equals, the first gray button at the top. This first option is numerator over denominator, which is a fraction, so we'll hit enter. Now we've got 4 in the top of the fraction, 3 in the bottom of the fraction. Only one 3. I'm going to go over and delete that number, the other 3. I used the right arrow to get out of typing from the fraction. Now I've got the fraction 4/3. According to the formula, next I multiply by pi, or its approximation, 3.14. And then I multiply by the number 6 raised to the 3rd power. You can type in the parentheses. You don't have to unless there's a negative sign there, which we're not going to see in volume because that number would represent a radius or a distance, and that's always positive. So we'll have times 6. Remember, to get the exponent to pop up, the exponent box, click this little caret top. When you click the caret top, you see a smaller version of the exponent there, a smaller version of the number. It's just going to be that little exponent box. If you're using a TI-83, you'll actually see the caret top symbol. And then we've got 3 as our exponent because it's cubed. Now we can hit enter. And the volume of that sphere is 904 32/100ths. And say 904.32. Volume has units to the 3rd power, and our units in this case are feet. We're measuring 3D space, so it's feet to the 3rd power. So I spent a lot of time on how to plug into the formula and use the calculator. I'm going to do that less on this next example. Here we've got a sphere, and again, the circular portion is given to us as what we normally see as the circle anyways. The middle part, but really there's circles going everywhere in the sphere, right? Anyways, sorry. So the length that's labeled 4 only goes halfway through the circle. Halfway through the circle is between radius and diameter. Halfway through the circle is the radius. so the radius is 4. Now this is a sphere. To find the volume of the sphere, the formula we use is 4/3 pi r cubed. So I'm going to rewrite that, 4/3 times 3.14 times a bubble for r to the 3rd power. I already know what r is. I don't have to find d. You already know it's 8 anyways. But we're going to put a 4 in that, substitute 4 in for r. And now you can use your calculator to figure out what the volume is. I encourage you to pause the video for a moment and try to type this in on your calculator by yourself and see if you're successful. If not, rewind the video, watch how I've typed in that expression, and then you can try that again on your own. So we've got 4 alpha y equals, enter, a 3 for the denominator, right arrow to get out, times 3.14, which is just pi, it's just an approximation for pi, times 4 raised to the caret top, 3rd power. So the volume there looks to be about 267, and if I'm going to round to the hundredths place, 95 hundredths. 267 and 95 hundredths. This is being measured in yards, so our 3D space being measured in yards tells us yards cubed. Now we've done one of each kind of sphere. I would go ahead, I would pause the video and attempt to at least set up the equations on your own. If you're struggling after that, go ahead and play the video, and then you can check for your answers at the end. I would take that moment and pause now, though, and try it on your own first, and then check yourself as you go. Hopefully you've paused the video by now and tried this on your own. So we've got a sphere. We need to look for the radius or the diameter, whatever is labeled for us. The distance through the circle that's drawn here only goes halfway, so that tells us that the radius is 5 inches. The volume formula for a sphere, 4/3 times pi times r cubed. So we rewrite that, 4/3 times, you can use the pi button or 3.14. Most of you prefer 3.14. Times something for r cubed. What am I going to substitute in for r, the radius? Well, the radius is 5, so I'll put a 5 there. From here, it's just calculator work. 4 alpha y equals, enter. Now I'm in the denominator, put a 3. Right arrow out of the denominator, times 3.14 for pi, an approximation for pi, times 5 caret top, gives us the exponent, and I need a 3 in the exponent box. The volume is about 523 1/3. This is inches, and we're measuring volume, a 3D space, so inches cubed. Looking at the next problem. We have a sphere, which is using some sort of circle, so I know I'll have a radius or a diameter given to me. I'm using a sphere. The volume formula is 4/3 times pi times r to the 3rd power. 3 is a line through the circle, through the middle of the circle, that goes from edge to edge, end to end. So that's the diameter. To go from diameter to radius, we cut that number in half, or divide it by 2, multiply by half, or divide by 2. Half of 3 is 1.5. Half of $3 is $1.50. Right, that's an invisible 0 behind the 5 there. 1.50 is the same as 1.5. Sorry, sidetracked. So now we can set up our formula, 4/3 times pi, or 3.14 as an approximation, or estimate, times something for r to the 3rd power. R is 1.5. From here, it's just calculator work. 4 alpha y equals, enter, 3. Right arrow to get out of the fraction, times an approximation for pi, times the radius, 1.5, caret top to get the exponent of 3, or 1.5 cubed. So the volume of that sphere is about 14 13 hundredths. 14 and 1300ths, 14.13. We're measuring 3D space, so our millimeters are to the power of 3. All right, so that was some sphere practice. Now I've got, these kind of look like boxes, and they have more than one triangle actually. Since these are boxes, there's rectangles and triangles involved. I have a prism. Since the triangles are the parallel shapes, this is a triangular prism. The next question is also a triangular prism. So take a second, see if you can't locate the volume formula for a prism from your star chart, cheat sheet, Google, any other method, notes. Hopefully you found the volume formula was capital BH. V equals capital BH. If you have me as a math teacher, I try to drill it in your brain. B does not mean base. This capital B means area of the base, and I tell you guys it doesn't even mean to pick a number that's given to you. It means you've got to pick a formula. That formula depends on what shape the base of the 3D figure is. If the base of the 3D figure is a triangle, you need to know how to find the area of a triangle. To find the area of a triangle, you use half BH. While we're here, let's go ahead and figure out how would you find out the area of a rectangle and how would you find out the area of a circle, because those are some other options we might have as far as finding the area of a base in a 3D figure are. These are some of the shape bases we might have. To find the area of a rectangle, you just take B times H, and to find the area of a circle, you take pi r squared. Important to remember here, the little b and little h are just the two numbers that make a 90-degree angle. And r, the radius, is the number that goes halfway through the circle. Okay, so some little side notes there about how to find the area of the base in these shapes. There is a video that explains why we use this formula to find the volume of 3D figures throughout my channel. You can go ahead and surf that and find it. Anyways, so V equals capital BH for a triangular prism. Prisms are named after their bases, so the base, hopefully you can see, is a triangle. You want to get a better look at the triangle. So that's kind of what it looks like. And it's really faint, kind of hard to see on the camera. Hopefully it's a little easier to see on your paper. There's a right angle marking right there. And the sides by the right angle marking are both 4, and the side across from that is 6. This is a right triangle, so the 4s are actually called legs, and the 6 is called the hypotenuse. For those of you math connoisseurs watching the video, this is not exactly a right triangle, it's just really, really close. If you were to use Pythagorean theorem, 4 squared plus 4 squared does not equal 6 squared, but it's close enough for the purposes of finding volume of a triangular prism. All right, moving on from that. I drew this so I could get a better look at the triangle, because I need to know some things about the triangle in order to find big B, and I need to find big B in order to find volume. I'm going to write down that big B is the formula of 1/2 BH, and I remember B and H are the two numbers that make a 90-degree angle. Well, here's the 90-degree angle. The two numbers that form that are 4 and 4. So big B is just half of 4 times 4. Half of 4 is 2 times 4 is 8. So big B is 8. The area of the base is 8 millimeters squared. This H, this little h, tells us how tall the prism is. The height of the prism tells us how we travel from one base to its matching base. How far apart are the bases? That would be that distance. from the top triangle down to the bottom triangle against this line, or this line, which is labeled as 8. So now that I know h, the height of the prism, and I know big B, the area of the base, the area of that triangle, we just substitute the numbers into the formula to find the volume of the prism. This bubble's in place of big B. Big B we've said was 8. The second set of parentheses is in place of h, the height of the prism, which we said was 8. So the volume of this prism can be found by taking the product of 8 times 8, which is 64. We are talking about millimeters, and the volume measures 3D space, so this will be millimeters cubed. We've got another triangular prism next. I need to know the area of the base, capital B, and the height of the prism, little h. To find capital B, the area of the base, I need to pick a formula to use to find big B. This is a triangular prism, so the base has to be a triangle. Take a minute to pause and see if you can't find which formula I should use to find big B. Hopefully you've paused, realized the base is a triangle, so we need to use the formula half BH to find the area of the base. I want a better look at that triangle. Maybe I'll redraw it or trace it at least. The back triangle shows us that the slanted sides are 7 inches. The front triangle shows us that the bottom edge is 7 inches. And there's an invisible line through the center that's labeled as 5 inches. And it makes a right angle with the bottom. Again, this is just approximately a triangle. It's not actually an equilateral triangle with a height of 5. Right, to find the area of the base then, I need half times the two numbers that form a right angle. Here's the right angle. The two numbers that form that right angle are 5 and 7. So to find the area of the triangle, we need half of 5 times 7. Half of 5 times 7 is 17.5. That gives me the area of the base B. I've got that. The next number we need to find is little h, the height of the prism. The height of the prism just tells us how far apart the two triangles are. How far apart are the bases? That would be from here to here. That line, which is the same as that dashed line on the left side, and this line that's got a label of 13 inches, meaning the height of this prism is 13 inches. So now that I know what capital B is, the area of the base, I have a value for that. I've got a value for the height of the prism. So if I take the product of area of the base times the height of the prism, I'll get the 3D space, or the volume, for this triangular prism. Take a minute to pause the video and see if you can't write down the product first. Hopefully you've paused the video by now. Instead of area of the base big B, we can substitute 17.5. Since we know the height of the prism is 13 inches, in place of h, we can substitute that with a 13. We've got now 17.5 times 13, or that the volume of that triangular prism is 227.5 inches to the third power, because we're measuring 3D space. The next shape we're going to work with is a cone. take a second and look on your star chart, your notes, Google, the cheat sheet that I've given you in class time and time again, some form to find the volume formula for the volume of a cone. Hopefully you found that the volume formula of a cone is 1/3 big BH. This is the same as the volume for a pyramid. That's because, whoops, this is because 3 cones will fill one whole cylinder, and the volume formula for a cylinder is big BH. So then 1/3 of, or times the cylinder, gets us the cone. That's where 1/3 times the cylinder comes from. So in order to find the volume of the cone, I need a value for big B, which is the area of the base, and I need to know how tall the cone is. Usually you guys are super awesome at picking out what the height of the cone is from the base to the apex, the point at the top, is 13 feet, which means the height of the cone is 13 feet. The shape of the base in a cone is a circle, so to find big B, or the area of the base, I need to know a formula for the area of a circle, which is pi r squared. So to find big B, I need to find pi times r squared. I've got a circle from end to end through the middle is labeled 7 feet. From one end all the way across to the other end is the diameter, so D is 7. To find R then, I've got to cut that number in half, multiply 7 by half, or divide 7 by 2. $7 split against 2 people is $3.50, or 3.5, or 3.50. So in order to find the area of the base, we take pi, or an approximation for pi, 3.14, and multiply it by the radius squared, or 3.5 squared. We'll have 3.14 times 3.5 squared. That's 38, and if we round, even as we don't have to round. If we round, it's already kind of rounded, 38 47/100ths. 38.47 about. All right, well, remember that the formula was 1/3 big BH. We already know a value for area of the base, big B. We now know the value, well, we already know the value for H, the height of the cone, which means we can substitute numbers or values in for those variables. And this set of parentheses for big B, we can write 38.47. In the next set of parentheses, we can write 13. This is really poorly written. That looks like 38.47, or 38.4 to the 7th power. That should say 38.47. So we'll do 1 alpha y equals enter. That puts the 1 in the numerator. And then I need a 3 for the denominator, times 38.47, the area of the base, times 13, the height of the prism. So then the volume of the cone is 166.7, if I rounded to 0.7. So volume is 166.7. We're measuring in feet. Volume is a 3D space, so the final answer with units is 166.7 feet cubed. It's just an approximation because we rounded so much between using 3.14 for pi and then rounding our answer for that as well in the ending formula there. All right, we've got one more cone. I would encourage you to pause the video. I've written the formula down. would encourage you to pause the video and see if you can't find the volume of the cone on your own, or at least find the two separate parts, the area of the base, and the height of the cone. Hopefully by now you've paused the video and tried to try that on your own. Big B stands for area of the base. To find the area of the base, we're going to use a formula for the area of whatever shape the base is. In a cone, the shape of the base is a circle, so we've used pi r squared. Instead of pi, I could say 3.14 times the length that's given to us through the circle, goes from edge of the circle to the middle of the circle, and that's labeled as 3. That is the radius, which means the diameter would be 6, but we don't need the diameter. We just are concerned about the radius. So 3.14 times 3 squared. 3.14 times 3 squared. 28.26. And that's for big B. This little h stands for how tall the cone is from the base of its shape to its apex. The base is right here, the apex is here. That distance that makes a right angle is 11 feet. So h is 11. Now that we know a value for big B, the area of the base, and a value for h, the height of the cone, you can just substitute those numbers into the formula for volume, 1/3 capital BH. And the bubble for area of the base, you'll put 28.26. And the bubble for h, we'll put 11. And then you pull out your calculator. 1/3 times 28.26 times 11. You see the volume is 103 and 62 hundredths. This is 3D space, so the feet, when I measure the volume, is going to give us feet cubed. Alright. Next, this is another box, but this time the bases, the two bases, the congruent shapes that are parallel from each other, are rectangles. So this is a rectangular prism. You might recall from earlier that to find the volume of any prism, we use the formula V equals big BH. So same thing here, V equals big BH, which means we need to know what the area of the base is, and we need to know what the height of that prism is. Big V, area of the base, does not mean to find a number. We've got to use a formula for the area of the shape of the base. The shape of the base in this figure is a rectangle. The formula to find a rectangle's area, BH, where that B and H make a 90-degree angle. You can see that the 90-degree angle marking is right here, which helps outline 11 and 7, meaning that little BH is 11 times 7, or that the area of the base is 77 centimeters squared. Okay, the height of the prism is just whatever length connects those two rectangular bases. So that's from here to the bottom corner. From the top to the bottom is 4 centimeters, so H is 4. That's kind of bugging. Okay. I've got that volume is a number for big B times a number for H. Now that we know values for capital B and H, we can actually just substitute those values into the formula and then solve. This bubble's in place of area of the base. Area of the base was 77. Second bubble's in place of height of prism, which was 4. Now we've got 77 times 4, which is 308. our units are measuring, we have a volume, so the units are measuring 3D space. So we've got 308 centimeters cubed. We've got one more. This is still a rectangular prism. I know a lot of you guys look at this and say, that's a cube. And you are not wrong. It is a cube. A cube is a special type of rectangular prism in which every edge is the same or equal length. Just like a square is a special rectangle in which every side is the same length. So a cube is to a prism as a rectangle, as a square is to a rectangle. Since a cube is just a prism, we use the same volume formula for a prism. Area of the base times height of the prism, which means we need to know how tall the prism is, how tall the cube is, and we need to know the area of the base. Since little h is just talking about one of the edges that connects the two bases, and I know every edge is 4, I know little h is 4. Capital B talks about the area of the base. So you need two congruent shapes that are parallel to each other. That's the top and the bottom. You could use left and right or front and back. Regardless of what you use, if you were to redraw the shape, you would see that every side is 4 centimeters long. To find the area of a square or a rectangle, the formula to find the area of a square or a rectangle is BH, just the two numbers that make a 90 degree angle. So in a square or a rectangle, all of the angles are 90 degrees. So I could say that this side and this side form a right angle. Those side lengths are both 4, so big BH, the area of the base, or BH, becomes 4 times 4, which means big B is just 16. We've got volume equals something for big B times something for the height of the prism. The first bubble is in place of big B. The area of the base was 16 centimeters squared. The second bubble is in place of height of the prism, or H. Height of the prism was 4 centimeters. Now we've got 16 times 4, which is 64. We're measuring volume, which means this is centimeters, 3 dimensions, but centimeters to the 3rd power. The last shape is a cylinder, and we talked about earlier how a cone is just a third BH because 3 cones fill up 1 cylinder. We get the BH from the cylinder part. We got 1/3 from the cone because a third of a cylinder will fill up exactly 1 cone, no more no less. That's because 3 cones fill up exactly 1 whole cylinder, no more no less. As long as the cone and the cylinder have the same circular base and the same height. In this case, we don't have that, so I can't just take 3 times whether my cone's number is owed on. We've got to do this the long way. We've got V equals big VH, which means I need to know the height of the cylinder and the area of the base. Area of the base does not mean pick a number. This is not 3. It does not mean multiply 2 numbers. 3 times 4 is 12. That's not what we're doing. The shape of the base is a circle. So big B stands for area of a circle. The formula for area of a circle is pi r squared. So to find capital B, I need to know a number for r. This distance goes halfway across the circle. This distance I'm pointing to is labeled as 3 feet. Since 3 feet goes halfway across the circle, I can comfortably say that the 3 is the radius. So to find big B, we've got pi, or an approximation, 3.14 times the radius, or 3, squared. 3.14 times 3 squared. We've actually already done this. 28.26. Now the height of the prism is just how we go from one circular base. Sorry, I said prism, I meant cylinder. That's how we go from one circular base to the other circular base, which is 4 feet. I called this a prism because this is almost exactly the same as a prism, except for instead of the base being a shape with straight edges, it has got infinitely many edges. So our base is a circle. Since it's such a special base, we actually give it a whole different name, cylinder. So the volume can be found by taking the number that we found for area of the base multiplied by the number that represents the height of the cylinder, the product of area of the base, 28.26, and height of the cylinder, 4. 28.26 times 4, 113 400ths. We're measuring 3D space, so the feet has to be cubed. I would take a moment and pause the video, see if you can't determine the volume of this on your own. If you have no idea where to start, I can help you get set up by telling you that the volume formula is capital BH. So you'll need to know a number for H. You'll need to know what big B is. Big B stands for area of the circle. To find the area of a circle, you use a formula, pi r squared, or 3.14 times whatever the radius is squared. That'll tell you a value for big B. You can find H by seeing what connects the two circular bases, and then you use those values to substitute into the volume formula for a cylinder. The only thing you would need to fulfill these is what the radius is. Remember, the radius goes halfway across the circle. All the way across the circle is labeled as 8. So 8 represents the diameter, which means the radius is 4. If you haven't already, pause the video now to make and try to solve that on your own for the volume. Hopefully you've paused by now. So to find the area of the base, pi r squared, you did 3.14 times 4 squared. 3.14 times 4 squared, which is 50.24. Height of the cylinder from one circle base to the other circle base is 12. When you're plugging in or substituting the values for your variables, the first value we substitute for is area of the base, which is 50.24. The next value we've got to substitute something for is height of the cylinder, which we said was 12. So now we've got 50.24 there, times ANS just means it's grabbing the number from the previous line, times 12. So the volume is 602.88 centimeters to the third power because we're measuring space. If volume still does not make sense, especially after watching this super lengthy video about all of the shapes we're responsible for in 8th grade math in Texas, please reach out to me through Schoology or email. My contact information can be found on the class app as well as Schoology. Contact me in class, yell at me a little bit to make some sort of before or after school appointment so we can learn some volume together.